Hello everyone and welcome back to my channel. In this video, this is the second video in OSPF series. In the last video, we discussed how to form neighborship in OSPF. In this video, we will discuss two cases which are very common that you may encounter while configuring OSPF neighborship. So those two cases will be number one will be MTU issue, and number two will be the area flag. So we will discuss first MTU issue, how MTU, because OSPF does not like fragmentation. So this is why MTU is very important. If MTU on both sides does not match, the neighborship will not form. So MTU must match on both sides for neighborship to come up. So area flag also need to match. Um, so now what is area flag? Area flag is something, on one side, if you're configuring, for example, stub area, the other side should also be stub area. And it's true for any other area that you configure, for example, NSSA. The other side should be NSA. So I will show you first the MTU and then we will move on to area flag. For the purpose of this lab, I'll be using this topology. So we're using R3 and R5 and we'll demonstrate on this side, we'll demonstrate on MTU issue. And this is where we'll see stub area. So let's look at R3 and R5. From our previous video, if you remember, we already formed neighborship between R3 and R5. So let's check it out. Okay, I just put the picture here so that everyone can see. So this is R3, this is R5. So we are on R3 at the moment. So if we check, this interface goes to R5. So if we check, we have a neighborship. Yes, we do have neighborship with R5. If we just quickly check the configuration on R5, simple, we have direct peering with R5. So here we have the same thing. Remember. Now remember this, if you notice this is slash 28 and this is slash 30. As long as this comes under lower subnet mask, like the higher subnet mask, it will form neighborship. So even if it's slash 29 and this one is slash 28, as long as both IP address are in the range of slash 29, they will form neighborship. So let's move on to the MTU issue. So currently what MTU size we have here. So if we look at it, this is an Ethernet MTU. So it's 1500 bytes. If we change MTU here, for example, if I go on R3 and I configure MTU to be, let's say, 1300. And if I just clear IP OSPF process, I'll just turn logging on and just do line console 0 logging sync. So if you look at this one, it was stuck in X start state. Now, if I debug this situation, debug IP OSPF adjacencies, so we'll see that in your debug, you will see that it says this neighbor has a larger MTU, interface MTU. So let's cancel all the debugs and just choose something else. So you remember you have seen this command as well. Um, so let's say if I do IP MTU 1500, MTU 1500, sorry, MTU 1500. Now it says the neighborship has come up. So this is a very common issue that you will encounter during your OSPF neighborship. If you see this issue, then just change MTU and just bear in mind that if you're using, for example, sub interface like .1q interface, then you have to change MTU on .1q interface rather than the physical interface, because OSPF uses the MTU for the interface where it's configured. Like if you're using any SVI, if you're using any .1q interface or anything, so then use that interface rather than the actual physical interface. So now we can discuss the area flag. This is the second most common issue you will get. So from the start, if we remember, so area flag must match on both sides. So what does that mean is, if one side is configured with stub area, the other side should also be configured with stub area. Now we'll see how we can configure stub area. So let's jump into the lab. We have R3 here and R4. We'll be making a neighborship on these interfaces, and we'll be making that area stop. So in this video, we will just see this issue, the area flag, but later on we will discuss each and every area in detail. So currently we have a neighborship with R3, but it is a normal area. So you see there is no stop flag here. Mm. Now let's make area 34 because R3 is connected via area 34. Let's make area 34 as a stub area. So router OSPF1 area 34 stub. So as soon as I configure this, so you'll see the adjacency has goes down, but it's not coming back up. Let's enable debug on this side, and we will see in the logs that it will give us that area flag mismatch. I think we will see it. Just wait a bit. Okay. Um, yeah, let's wait a bit, and we will definitely see on one of the other sides that area flag is mismatching. And now if we look at show IP OSPF neighbor, we'll see that the neighbor with R3 is in downstate. So remember we discussed in our first video what downstate means, that it hasn't started received hello packet from the neighbor yet. Okay, so OSPF neighbor is in downstate, which means it hasn't received any hello packet yet. So in order for this adjacency to come up, we have to configure R3 with stop. So R4 is a stop area. And we have to match this on this interface. So let's configure this here. So it's 0/4. Oh, sorry, not here. Router OSPF 1 area 34 stop. Oh yeah, it has a virtual link. Sorry, just remove. I just need to remove my old config that I did, and then we'll be good. Uh, So we will discuss virtual area later on in my next videos because it's very important to know that in virtual link you cannot configure that area as a stop. So that's a basic requirement of configuring virtual links. So now if we see that the neighbor between R4 is now in full state, but now let's go ahead and check the routing table for that neighbor. So if we configure stop area, remember it will not receive any external routes. It will only receive intra-area routes. So routes that it learns from area border router ABR, and routes that it contain within its own area. So if we configure that area, so because there are multiple keywords that we can add, for example, area 34 stub, and then no summary. Let's see what happens. So it's still gonna form neighborship because the area flag means whether it's normal area, stub area, or NSSA. So that flag needs to match. What I added in a no summary is just a property for that area. So, but if we check the routing table for this, you will see now I only have the summary route, like the default route. So what that means is, so if you configure area stub and then no summary, it will only advertise the default route to its neighbor. So it will not advertise any inter area routes, and it will not advertise any external routes. So this is a very large topic where we are going to discuss some LSAs, LSA 1, 2, 3, 5, and 7. And I will make a very detailed video. So probably next video will be very detailed based on area flags. Sorry, not area flag, LSA type. So once we understand LSAs, then we move on to our next video that will be about area flag, and we will be able to better understand area flag. So stay tuned. Next video, it's going to be a lot of theoretical lesson. So it's going to be all LSAs that we use normally with OSPF version 2. No. Thank you so much for watching this video. If you like this video, please subscribe to my channel and suggest anything that you have in your mind via the comments. Thank you so much.